Again, using the idea that we can apply our normal distribution to real life problems just by transforming it into our z-values or our z-scores. Looking at the next couple examples here, it says each month an American household generates an average of 28 pounds of newspaper for garbage or recycling. Assume that the standard deviation is 2 pounds. So if you look at the bell curve right here, what this is coming from, it says if a household is selected at random, find the probability of it generating, and we're just going to focus on A right now. We'll do B in a second. Between 27 and 31 pounds per month. So here, obviously, is our mean on average of 28 pounds. We know it has a standard deviation of 2 pounds, and we're looking for between 27 and 31. So what we want to do is take that 27 and 31 and translate it or transform it into z-values. Excuse me. So I'm going to say our first z-score here. Remember, we do that by taking the value minus the mean and dividing it by the standard deviation. I'll say that this is our first z-score here. I'm going to go 27 minus our mean of 28 divided by our standard deviation of 2. And that works out to be a negative half, negative 0.5 and negative 1/2. Our second z-score here for the 31, using the same formula, is going to be 31 minus our average or our mean of 28 divided by our standard deviation of 2, and that works out to be 3/2 or 1.5. So if you look here, okay, what we're looking at when we do our table is that our mean is 0, and this is a negative 0.5 and a 1.5. So when you go to do the table, our first z-score at negative 0.5 is going to correlate to 0.3085. And our second z-score, which correlates to 31 here, or is 1.5, is going to go to 0.9332. The reason drawing this bell curve is helpful is because we can see here we want the area between those two numbers. So we know we just have to subtract them. And when you do that, you get 0.6247. What does that mean? Well, remember, it wants to know if a household is selected at random, find the probability of it generating between 27 and 31 pounds per month. So we can say that about 62.47%, again, we can use percent, percent's out of 100% or out of 1 as a decimal, and so is the area under this curve, which is the reason why this is really beneficial for real life problems, because there's not a whole lot of translating or transforming you have to do besides your z-value. But we can say that 62.47% of the households generate between 27 and 31 pounds of garbage or recycling each month. Let's look at part B. Now we're going to focus here and we want to know, hey, what is the probability of it generating more than 30.2 pounds per month? So if you draw your bell curve here, our average, our mean is still here at 28, and we want to know what's greater than 30.2. Remember, using our table, that's always the area from the left. So when we see some area to the right, we know we have to go 1 minus. But before we get there, we have to transform these into z-values. Pretty much doing the same thing over and over. In this case, I'm going to take 30.2, subtract my mean, divide it by my standard deviation, and I get 1.1. So if my z-score is 1.1, on my table, I can see that correlates to 0.8643. So if a household is selected at random, find the probability of it generating more than 30.2 pounds per month. It's not 86.43. Remember, because it's to the right here, we have to go 1 minus this, which works out to about 0.1357 or 13.57%. 13.57% of the households are going to generate more than 30.2 pounds of garbage or recycling, newspaper for garbage or recycling each month. So use the curve to know whether, in this case, we got to go between, so we find the two values, or we have to go 1 minus if we're looking to the right. One more example. The American Automotive Association reports an average time it takes to respond to emergency call is 25 minutes, and we're going to assume that it's approximately normally distributed. The standard deviation is 4.5 minutes. If 80 calls, okay, going to come back to that, are selected at random, how many responded to in less than 15 minutes? So just like we've been doing in all the other examples, let's take this information. We have our curve here. We see that we want less than 15 minutes. Okay, so we just need to find the area up to 15. But we always start by finding our z-score, our z-value. So our value is 15 minus our average or our mean of 25 divided by our standard deviation of 4.5. That brings us to a negative 2.22. So if our z-score is negative 2.22, we can look in our chart, okay, and that's going to correspond to 0.0132. So which basically is 1.32% of the emergency calls are going to be responded to in less than 15 minutes. But you have to take this one step further. Remember I said we're going to come back to this 80 calls. Okay, it's giving us a number. It's just not saying a percentage. It wants to know exactly how many. Once you have the percentage, though, it's not that hard to figure out. We know about 1.32% are going to be responded to in less than 15 minutes. So if we have 80 of those calls, and we want to know how many are going to be responded to in less than 15 minutes, we know that percent. Again, use the decimal. You just have to multiply these together. And you're going to see that works out to be about 1.056. So approximately one call is going to be responded to in under 15 minutes. Okay. Again, using our z-scores, doing the same things, but when they give us an actual number, we just have to multiply that by the percentage or the decimal equivalent to figure out the exact number out of that total.